Hi everyone, this is MathsForUni. Today I'll be discussing part 1 of Step 2, 2019, question 2. If you find this content helpful, then please consider liking and subscribing, as well as checking out both of our Udemy courses, of which the links are in the description. This part of the question says, the function f satisfies f of 0 equals 0 and f prime of t is strictly greater than 0 for t greater than 0. Show by means of a sketch that for x greater than 0, the integral from 0 up to x of f of t with respect to t plus the integral from 0 up to f of x of f inverse of y with respect to y is equal to x times f of x. So again, let's reiterate the conditions that we have. We have this function f, and f of 0 is 0, so the curve goes through the origin, and f prime of t is positive for t positive. So this must be an increasing function. So let's start by having a sketch of this function, and we're only interested in the positive quadrant because this function is increasing and it starts down here. So here we have our x, let's say, and here we have our f of x, and let's pick a particular value of x to go up until, and let's draw out what our function looks like until that point. Because it's increasing, it looks something like this, where round here I've drawn it slightly wrong because it shouldn't actually go down, it should just be entirely increasing, but that's kind of the idea. And so we have this x here, and then correspondingly, this is the value f of x up here in the y direction. And then here, let's identify some of the areas that we have involved, because we're looking at an integral relation that we want to show. So let's say we have the area here A and the area in here B, where A is this area enclosed in here, and B is the area enclosed in here. So what exactly is A to start with? Well, A will be the integral from where we start, that's 0, up until x, so 0 and x, and then let's use another variable, so let's say, as they've done here, t. Let's do, well, this is the curve of essentially y equals f of x, or f of t, or however you want to do it. And so we have f of t dt, because we're looking at the area underneath this curve here. So that's the area of A, but how about the area of B? Well, if you think about it, rather than integrating in this direction, we can calculate this area here by integrating in this direction. So we're integrating from 0 at the bottom, where we start down here, up to here, which is f of x in height. But then, what exactly should we integrate? Well, because we're on this side and going in this direction, then we can consider, let's say, we have y is f of t, that's our curve, and we've got the parameter of t as our variable. That parameterizes this curve here. Well, if we're going in this direction along and integrating in y, then we would want to solve for t, and we'd have t being f inverse of y. Now, not all functions have a well-defined inverse. However, ignoring this point here that I've drawn where the function should not go down, but it does, we have this condition here, and because it's increasing, this means that this must be an invertible function. And so, indeed, the inverse exists, and we can write this. Now, usually, when finding this area here, we integrate essentially y, the height of this curve, over all of the points involved, but for this direction here, we're essentially integrating our x, or in this case, our t. And so we're integrating t with respect to y. But as we have here, in terms of y, this is the integral from 0 up to f of x of f inverse of y dy. If you're not familiar with this, then look up online integrating over the y-axis, or bounded by the y-axis. So now we've noticed that a and b are quite similar to what we have in the integral relation that we want to show. In particular, we consider a plus b, and we want to show that that's equal to the right-hand side, which is x f of x. Well, quite nicely, a plus b is the entire area of this rectangle here. The width of the rectangle is x, and the height of the rectangle is f of x. And so, quite easily, we get x f of x, and so putting in a and b in terms of their integrals will give us the integral from 0 up to x of f of t dt plus the integral from 0 up to f of x of f inverse of y dy is equal to x f of x. This concludes our discussion of this part of the question. Take a look at our future videos for the next two parts. If you found this content helpful, then please consider liking and subscribing, as well as checking out our Udemy courses. The links are in the description. Thanks for watching, and goodbye for now.